For this case study, we are showing how to calculate a one-way ANOVA table by hand. In this problem, we are finding if the battery life of 3 different brands of batteries is the same. For step 1, we are setting the hypothesis. The null hypothesis, or H0, is that all 3 brands' means are the same. The alternate hypothesis is that there is at least one difference between the means. We are also evaluating this at a confidence interval of 0.05. For step 2, we are finding the degrees of freedom. To find the degrees of freedom between groups, you do k, which is the number of conditions, minus 1. In this problem, k equals 3. So, the degrees of freedom between groups equals 3 minus 1, or 2. To find the degrees of freedom within groups, you do n, or the number of scores in the total samples, minus k, or 21 minus 3 in this case. To find the total degrees of freedom, you just do n minus 1, or 21 minus 1, to give you 20. To find the F critical value, we use a table. The horizontal degrees of freedom are the degrees of freedom between, while the vertical degrees of freedom is the degrees of freedom within. So we go to 18 and 2, which gives us a degrees of freedom of 3.55. For step 3, we are calculating the sum of squares. First, you will need to calculate the means of each individual brand. You do this by summing up each value for the brand, then dividing by the total number, which in this case is 7. So, the mean for brand 1 is equal to 44.57. The mean of brand 2 equals 45.86. And the mean of brand 3 is equal to 48. Next, we will calculate the grand mean. To find the grand mean, we will sum up each value of the brands, then divide by 3. In this case, we got 46.14. Now we will finally start to calculate the sum of squares. The sum of squares is equal to each value minus the grand mean squared. So, in this case, we calculated the sum of squares total to be 458.5716. The sum of squares within equals the data of each individual brand minus the brand mean squared for each value. In this instance, we got a sum of squares of within to equal 416.5715. The sum of squares between is the sum of squares total minus the sum of squares within, which equals 458.5716 minus 416.5715, or 42.001. Next, we will calculate the variances for step 4. The variance of between equals the sum of squares between divided by the degrees of freedom between, or 42.001 divided by 2, which equals about 21. The variance within is equal to the sum of squares within divided by the degrees of freedom within, which equals 416.5715 divided by 18, which equals 23.14. Next, we will calculate the F statistic for the data set. The F value is equal to the variance between divided by the variance within, which equals 21 divided by 23.14, or 0.91. 0.91 is less than the critical value of 3.55. Ignore this. So we fail to reject the null hypothesis, H0, which means that there is no difference among the means.